Okay. Today we're going to look at domain and range, but primarily we're going to focus on domain. Okay? So vocabulary-wise, what we mean by the domain of some function. You remember we had this big group that we're going to pull independent variables out of here. We're going to apply some rule, and then it's going to find values over here in this big group here. The domain of a function means, especially in mathematical terms, if this big group is all real numbers, if I pick a real number and apply my rule, it must find a real number in the other group. So if I have some independent variable that when I apply that rule to it, it creates something not real, not a non-real number, then that number cannot be in the domain of that rule. So when we're looking for domain issues, we're looking for what could cause a function to create something that is not real. So what are the two things that we know that cause a number to be not real? There's two main things we need to look for. If what is negative? The number in what?
The denominator in a fraction is zero.
There we go. If you're talking denominator, it's 0. So that would be the first one. If I have a denominator, then x cannot be 0. You cannot divide by 0. Okay? If I attempt to divide by 0, I create something that is not real. So anytime we have a denominator in a function, and that denominator contains a variable, we have to make sure that that denominator cannot be 0. So what's the other one? You're headed in the right direction with negative.
Square root of a negative number.
There we go, the square root of a negative number. So if I have a square root, then what's in the square root has to be greater than or equal to 0. It cannot be a negative value. Okay? So these would define domain restrictions that we have to pay attention to. Okay? Now, we also want to pay attention to the fact that it isn't just x that has to be 0. In this case, the simplest form of this is 1 over x, but suppose I have 1 over 2x plus 3. Well now, my domain is not x cannot equal 0. If x equals 0, this turns out to be 1/3. That's a real number. Okay? What is not allowed to be 0 is the denominator itself. So what we have to do is take 2x plus 3, and that is what cannot equal 0, and then we have to solve that equation. And once we solve this, that will give us the specific x values that are not allowed. So this would be 2x cannot be negative 3, so x cannot be negative 3/2. So the domain restrictions for this function would be x is not allowed to be negative 3/2. Okay? Same issue over here. If I have a function, the square root of 4x plus 5, it isn't x that has to be greater than or equal to 0. It's what's inside the parentheses that has to be greater than or equal to 0, or inside the square root. So in this case, my domain is 4x plus 5 has to be greater than or equal to 0. And now I simply solve that little problem. So subtract 5, and I get 4x has to be greater than or equal to negative 5. So x has to be greater than or equal to negative 5/4. So there are, in fact, some negative x values that could be used, but only ones that are greater than or equal to negative 5/4. Any numbers less than that, when I plug them in here, are going to create a negative number that I need to take the square root of, and that's what's going to cause me my problems. Okay? Now, range, we'll go over range fairly simple. The only problems you're going to have looking at range are with a graphing calculator. The range is simply all the values that are found by the values that are in the domain. So every domain value that comes over and finds a number, all of the possible numbers are the range. So we'll look at a simple one, y equals x squared. We would get this for our graph. So for the range issues, we're going to basically just use a graphing calculator. So those problems that ask you for range, you're going to have your graphing calculators available. So domain-wise, do I have a denominator that contains a variable? No. Do I have a square root that has a variable in it? No. So the domain is all real numbers. Okay? But now, when we look at the graph, what y values are capable of being discovered in this function?
Positive numbers?
Greater than 0.
Yeah, only the numbers greater than 0, because my graph only goes up. None of these y values are ever found in that function. So my range is y must be greater than or equal to 0. So when you're looking at domain, how much of the x-axis is in your graph? For range, how many y values are in your graph? So this graph keeps going out forever, so it's all real numbers in x, but it only goes up from 0. So there are no negative numbers, so you have a range restriction. Okay? So let's just try a couple of sample problems.
This is for you. That's to determine what the student's doing second period.
Oh, okay. Oh, for second period?
Yes, sir.
Okay.
Thank you.
Okay. What we want to do is find the domain of each of these functions. So for this one, what would be the domain? All real numbers. The first thing you do is look to see if you have a problem. And if you don't have a problem, then any number will work. So I have no denominator that I have to deal with, and I have no square root that I need to deal with. So the domain is all real numbers. Okay? Now, what problem do we have with this one? We have a denominator. When you have a denominator, the issue is the denominator cannot equal 0. So we're going to take 3x minus 5 and say that that cannot equal 0. Once we've established this, then we simply solve that little equation that we created. So add 5, divide by 3, and x cannot equal 5/3. Okay? Which problem do we have here? Square root. Now, the square root problem, whatever is in the square root must be greater than or equal to 0. Again, it's not just the x, it's whatever is in the square root. So now we've created a little inequality, and we just need to solve that. So subtract 8, so 2x has to be greater than or equal to -8, divided by 2, and x has to be greater than or equal to -4. Okay? So, domain issues are pretty straightforward. Just have to pay attention to your basic, simple equations and inequalities, but not always so simple. so we look at this first example. Which problem do we have? Yeah, we have a denominator. So our denominator cannot equal 0. So now it's a quadratic equation, so we simply solve that equation. Just treat this as if it's an equal and solve that equation. And what do we get? How do we solve that quadratic? Factor it. So how do we factor it? We want to find two numbers that do that. Multiply to be 6 and add to be 5. So there we go. So x plus 2, x plus 3, and then we set each one. So x plus 2 cannot equal 0, and x plus 3 cannot equal 0, because either one of those will cause it to be 0 in the denominator. So our final domain is x cannot be -2, and x cannot be -3. For this one, now we have which problem? Square root, right? So whatever is in the square root has to be greater than or equal to 0. Now we have a quadratic inequality, so we have to figure out where is that graph positive and where is it negative. So to do that, we're going to set that equal to 0. So 9 minus x squared equals 0. This factors to what?
X plus 3, x minus 3.
Well, 3 minus x and 3 plus x. You'll get the same answer either way, but it's just a subtle little difference between the two. So this is going to give me x equals 3, and this is going to give me x equals -3. Now, these are the places where that function is equal to 0, okay? Well, the only way that a function can change signs, we're concerned about this. Where is it greater than or equal to 0? So we need to know, where is this function going to be positive? A function can only change from positive to negative if it crosses the x-axis. That is, it passes through a 0 point. Since these are the only two 0 points, everything greater than 3 is going to be the same sign, no matter what it is. And everything less than -3 is going to be the same sign, whatever it is. And everything between -3 and 3 is going to be the same sign. They can't change unless there's a 0. So those are the only places it can change. So what we're going to do now is just pick a number in between -3 and 3. 0. If I plug 0 in for x, I get 9 minus 0. And that is a positive number. Pick a number bigger than 3. 4. 4 squared is 16. 9 minus 16 is a negative number, so all of those have to be negative. Pick a number less than -3. -4. -4 squared becomes positive 16. 9 minus 16 again is negative, so it's negative there. So the area, the x's are included, so you can do it either way. There's your graph of it. In interval notation, this would be, my domain is -3 to 3. Or if you prefer, you can write it -3 less than or equal to x less than or equal to 3. Okay. For this last one, what problem do we have? Both, okay? You can have situations where you have more than one domain issue that you have to deal with. So we have something inside of a square root. So we know that 4 minus 3x has to be greater than or equal to 0. But now we know what else.
It can't.
This is in a denominator, so it cannot equal 0. So I'm simply going to take the equal off my inequality, and that will take care of both of the restrictions that we have to deal with. Now I'm just going to solve this, so subtract 4, negative 3x is greater than negative 4, and now I'm going to divide by negative 3, so x is what?
X is less than 4.
What happens to an inequality when you multiply or divide by a negative number? The inequality reverses. So because I'm dividing by negative 3, the greater than changes to less than, and then of course negative 4 divided by negative 3 is positive 4/3. So in this case, only numbers less than 4/3 are in the domain. Okay? So when you're solving these inequalities, you just have to remember all those little rules for solving equations that are inequalities. Any questions about the concept of domain or what to look for and how to determine what domain is? Yes?
On the last one we did, do we still need to determine if, do we still need to find out if 4 minus 3x is not equal to 0?
We took the equal 0 off of the inequality, and that takes care of that. So if it equals this number, it will be 0. Since it's in a denominator, we eliminated that. So we don't have to have a separate statement that says not equal because we removed the equal from the inequality statement. Okay? Any others? Okay. Have fun. Don't forget, what are we doing tomorrow?